Alright, draft physics. I guess I'll do this in a couple of pieces and then put it together. Because, there's always, you hit a point where you just say, oh, that's enough of that. So it's Hythloday. So I got through 7 minutes of this so far. Where he just doesn't really get to too many points. Still griping about angular momentum. I mean, I think it's an appropriate use of the term just in the sense that we're really talking about things flying into like solar systems and getting caught up in gravities and bouncing off of this and swirling around that. And I think it's appropriate to use the word in that circumstance. I'm basically calling electrons, or the function of atoms, gyroscopic. So I think angular momentum is the appropriate term to use because, yes, whether it's a momentum it got from a purely kinetic reaction or a momentum it got through a, bending around something else's circumstance for some other reason, it doesn't really matter. But anyway, no point in arguing. I'm going to try to say directional momentum. So from now on, I'll just say directional momentum, even when I mean angular momentum. So even in a circumstance where it's angular momentum, I'm just going to call it directional momentum, and then I've covered them all. Because it's basically going to be the same thing. So, semantics. Okay. There. I've resolved that problem, hopefully. So then he makes this accusation that I have interchanged the words acceleration and velocity. Well, I've seen even the great physics professors make these little mistakes now and then. Sometimes they say like light is 300 million miles per second or something instead of meters, and vice versa. And so yeah, everybody can make a mistake now and then, but I've clearly demonstrated I know the difference between acceleration and velocity. And but what I'm claiming is unlike other people are saying velocity is irrelevant, I'm saying no, velocity is incredibly relevant. And you don't escape its relevancy, and so in a sense velocity and acceleration are the same thing. So even when you're not moving and you're being accelerated, you still have a velocity technically, in terms of your internal structure. So it really doesn't, I mean, look, the bottom line point is it's just going from one state to the other state. And but obviously if you already have velocity and you accelerate, you already have velocity, you're just adding more velocity technically, and there's not that big a distinction, except acceleration has a time limit thing. Acceleration has an additive implication, but that's it. It's an additive implication. That's the only distinction between accelerating. The first time I push you, okay, say I'm going to be accelerating you. The first second I push you, okay, I'm creating your velocity. So, there's no, how to put it, because you didn't have any before I started accelerating you, right? Right. Well, technically none that you knew of, but that's sort of the point. But anyway, I do know the difference, so it's just idiotic. I make the point in the videos that, it just doesn't, I'm just saying for the purposes of light, production of light, for the purposes of when I'm shining a flashlight, it doesn't fucking matter whether I'm accelerating or I have velocity. The light still isn't going to have momentum. So if I'm moving sideways, and I have this little laser pointer, I'm going sideways, the little dot of light over here, right, isn't going to keep up and come flying over there. Okay, it's not gonna go the direction I'm going. It's not gonna carry my momentum with it. It's gonna go that way. I'm gonna go that way. All right, that's the way light works, and that's the fucking point. And it doesn't matter whether you're accelerating or you just have velocity. That's the fucking truth. Acceleration and velocity don't make any goddamn difference to the fact that this is going that way. It's not going that way. Okay, it's not going to keep up. And so that's where relativity just falls on its fucking face, with its idiotic notion that somehow the light has momentum, besides the direction it's going in. No. Alright, anyway. Okay, that's probably enough on that one. Deceleration is an interesting concept, and see if I can work something out with that. But well, clearly the distinction between the Sage theory and Einstein's theory. They're both convergence, right? So that we could agree on, right? This is basically you're saying whether it's a convergence of photons in the sense that they don't necessarily go down a drain, they just go through everything. But they do push it in that sense. They have an effect on it. They change it by going through it. See, that is a distinction, right? I mean, Einstein is kind of pulling, you know, with his bent space. I mean, there is this idea of falling. It's not this idea of you being compelled to go there. It's an idea of you being dragged there. But well, look, the point is that I would think there's got to be an experimental way to detect this distinction, you know, between absolute velocity and relative velocity. And you can't do it with known clocks. You can't make a clock that isn't going to be subject to the velocity of the frame you're, you know, measuring the velocity in. You know, that isn't going to be moving. There's no outside the elevator where we can put a clock. And that's sort of the catch. But maybe there's some other constant, some other thing. I mean, radioactivity is sort of interesting, but that's also subject to this whole idea that the metabolism of the atoms is slowed down by velocity. So again, it's getting the clock out of the velocity. So it's creating a gyroscope that is, that's kind of the thing I've been thinking about, is gyroscopes. I've been thinking they have to go to a default position eventually, right? I mean, they'll always default to some force. So if I shoot out of the Earth's gravity, the gyroscope is going to turn to something. It's not going to turn nowhere. It has to adjust to some other force, some other position that is the non-Earth gravity position, one would assume, correct? So if you can get far enough from the Earth and the influence of its gravity, you can figure out what other gravities are pulling on the gyroscope. Yeah, it's still not going to tell you velocity. I've got to think of some... Well, anyway, wasting time on this mush. But the difference between me and you, okay, so now we get to the personal shit. He wastes 7 minutes of this video just doing this blah, 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 bitching. He always uses the term first blood. It's not the first time he said this. You know, that's the whole point. You people, I've said it to your faces so many times. You think asshole is unacceptable, but you can call somebody ignorant, and that's where everything goes sideways. Okay, you think you can be pompous, arrogant, insulting, and it's okay. Your insults don't count, because they're not vulgar. Is that it? So because other people will fall for it, because they'll accept your arrogance and your obnoxiousness and your patronizing attitude, because they are too stupid to be insulted by it, doesn't mean I am. And I will react to it, and I'm not going to react to it with a bunch of, you know, nerdy pussy talk. I'm going to call you what you are, an asshole or a jerk. Yeah, that's what I'm going to do. So then he says he's going to give what he's going to get, and then he says, but I'm a pussy and I can't watch videos that are too harsh and nasty. Sorry, buddy. You can't play it. You can't have it both ways. And again, I'm going to say, if anybody analyzes the circumstance, I never draw first blood. I just don't. Somebody else does something really obnoxious, or they do something obnoxious to something that they have no right to do, like call them beasties and say they don't have sentience. Yeah, you can do that. If you insult one of my friends, an animal, yeah, I'll come to their defense too. But anyway, so that gets us to this random and arbitrary phrase that you constantly use. Everything's random and arbitrary, apparently, to you. And it just doesn't make any sense to me how you can call a school of fish moving in a direction random and arbitrary. I mean, obviously, if the school of fish is moving in a direction, it has changed its configuration. More fish have to be moving in the direction the school of fish is moving in. How could that possibly be random and arbitrary? How? Now, I'll play this clip.
And you saying that if the fish is swimming this way and fish are swimming this way, that they have no interaction, that they only interact perpendicularly, if you like. I hear that, but it seems so random and arbitrary.
There you go. Random and arbitrary. So this is a basic kinetic law, right? I mean, that if that there is a distinction, okay, between, say, two cue balls, okay, that interact at some other angle, right? So if the two cue balls crash into each other in a straight line, there's no visible difference in what happens, right? The cue ball going that way goes that way, and the cue ball going that way goes that way, and there's no visible distinction. You couldn't tell if they missed each other and they hit each other. You'll see no difference in the end result. And two cue balls coming at angles, okay, that quite obviously now will leave at completely opposite angles. So you'll have a completely different consequential end result. In one circumstance, after the effect, there is no effect. You can't even tell it happened. And in the other one, you can tell it happened. It's a completely different world that now exists. The pool balls are going in different frickin' directions. Okay? If they would have missed each other by just a little tiny bit, the world would look entirely different than it looks because they hit each other. That's not random and arbitrary.
Because remember, these photons allegedly are rotating, orbiting, helicking, or whatever, and thus they're not really. The only time that they are travelling completely laterally, so to speak, in this particular sense, is when they're travelling the speed of light.
They're traveling the speed of light all the time, and it is correct, that's why I was using angular momentum, that they are spiraling. But let's just forget the spiraling for now. I mean, the spiraling deals with the fact that they are moving less than the speed of light in the spiral. Okay, the spiral is moving less than the speed of light. But again, the photons themselves are not. And the point is not what every photon is doing. The point is, what is the majority of the photons doing? So if the spiral is moving in a direction, then the majority of the photons in the spiral will be moving in that direction. More, like whatever, 50% will be going this way, and 20% will be going this way, that way, and 15% will be going that way, and 10% will be going that way. I mean, you can just figure out that there'll be a percentage, and that the predominance of the photons will be going actually that way, or in some variation of that way. So, and we know that more than 50%, definitely more than 50%, will be on this side of the angular curve than this side. This side gets less than 50, this side will have more than 50, quite obviously, in net directional momentum. There, I did it. Net directional momentum.
So I can't see why there would be less points, or should I say, why there would be more points of collision laterally as opposed to head-on some solid object.
Okay, well, if the photons, again, are directional, okay, so the gravity has a direction overall, and it's getting shielded from one side, so only one side of the gravity is being relevant, right? Because we're saying basically it's getting shielded from gravity on one side, so the gravity that's of incidence or importance in this equation is the gravity opposite, the force opposite the side that's being blocked by the gravitational object. So the gravitational object casts its shadow, so we're really talking about the stuff on the opposite side of the shadow and what's it's doing. So when it's coming into the thing, and no matter what its momentum is in any other direction, all this other stuff, the point is when it's moving in a direction, it's moving against something that's coming at it. Okay? It doesn't move into the pressure is moving into it. So it just has to kind of be understood that way. This is the pressure. This is the high pressure. The thing is the low pressure. The high pressure is moving into the low pressure, and then the relevant point is it's moving against its first it's for gravity it's moving against the opposite dead side, and for any velocity the thing has moving all by itself, just moving through space, for example. When you're just moving through space, you're in the pressure field, the gradient. There's just nothing blocking you from the gradient, so the pressure is equal on all sides. But at each side, the pressure comes in. But if you're moving in a direction, there's going to be less pressure, because you can understand the fish that are the amount of the number of fish that are going in the direction you're coming from. So you're coming from this. Well, I just give you a piece of paper, right? Yeah, that makes things a little better. Oops. Sorry. Flipping pages is, you know, semi-complex physics. All right. So yeah. So we'll just do this up and down thing real quick. I'll try to be real quick. So look, we're just basically saying, again, I'll just use 5 arrows, you know, just to signify the fact that we know the fish are doing different things, but then the majority of them are doing one thing. So the majority of the fish, 3 fish, are coming at you, one's going away from you, one's going sideways, kind of arrangement. And your back door is exactly, you know, the opposite, right? There's 3 going away from you, 1 coming at you, and 1 going sideways. But that's how the school moves, okay? The school, when the school is just schooling, okay, when it's not moving towards you, alright, then you have an equal number of fish going this way, an equal number going that way, an equal number going that way, an equal number going that way, and all the variants of those directions. So every sub-angle of those directions is obviously proportional to these ratios. So you would have this evenness of pressure. The fish don't go anywhere because no significant number of them are going one way more than going another way. But obviously when you're moving, that has changed. So now more fish are moving towards you, if that's how we're looking at this, the velocity coming towards you and why it doesn't create extra pressure. And relevant to the other video you'll presumably will get to, and the point I just made with the laser pointer, this fish going sideways, so all the variants of this sideways movement, okay, is not, okay, does not have the momentum of this fish. It does not have the momentum of this fish. It does not have the momentum of this fish. It is not moving forward, okay? It is moving that way, okay? So as these fish move forward, they're going way, they're down here. This sucker's stuck way back here. That's the point. It's the amount of time in the orbit of the gyroscope that is spent at one end or the other end, or on one of these 4 sides. It's the amount of time in an orbit that you have to access. You see, you got less time to access the sideways things as the orbit stretches out, and you have obviously more time on the sides, but you can't hit them from the side when you're coming at them, correct? So the only ones you can hit are these. And as you accelerate, as you gain velocity and you go faster and faster, the amount of time you can impact one of these guys going sideways gets smaller and smaller. So you run out of time to hit one of these. And that's how the pressure gets equalized from the front to the back. Because the back, okay, is seeing exactly the opposite. And these sideways fish, relative to the front, aren't moving. They're right there to be hit. It can still hit them just as easy as before because they're not moving. They're right there to be hit. So the pressure is equal from the circumstance of the fish not moving forward. So the ones not moving, okay, are just as hittable by either side. You should be able to get that. I mean, I know, look, sometimes you got to explain something in more than one way, so I'm sorry for people who already get it. But yeah, maybe this has to be go over a few times before people get this thing, that the momentum, again, of the light, of the fish, this is the fish going sideways, okay, let's say this beam going up, right, this beam, alright, so when it's coming at you, it's purely kinetic. When it's going sideways, it's moving backwards relative to the beam of light I just shot this way, right? If the beam of light shooting this way, the beam of light going the sideways is losing ground fast, especially to a light beam, right? I mean, that thing is shooting out. It's it's 186,000 miles a second. In 1 second, it just, whoa, it's gone. I mean, the school has left me way behind. So I obviously can't be going sideways too often, or I would be left way, 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 way behind. So I can only go sideways for the little briefest moments. In terms of time, you don't have time to go sideways. And remember that velocity is constant. So time is the only thing you can change to regulate exposure, or reality in existence. You can't be in existence more by gaining more velocity, so the only thing you can do is change how much time you're doing something. You can't change how fast they're doing it. Photons can't change how fast they're doing something. They can't, so they have to change how long they do something. Ooh, that should say it. Yeah, I like that. Alright. So I don't know, I'll play his video from here, the 8:10 moment, and we'll see if there's anything else that has to be said, but I think I've explained it again, so whatever his complaint is, I think I've covered it. We'll see what his next complaint is. Alright. Yeah, that seems fair. Alright. Yeah, I don't really want to break here, but some of these points he's raising are so obtuse, or, you can't take appropriate notes to say this is how I'll respond to that, and there's such open questions like why are electrons held together or something, questions Einstein didn't answer. So what's Einstein's answer? He doesn't give answers to any of this stuff at all. So you want me to give you an answer? Yeah, whatever. I can give you a description of a model that'll work. I can't tell you the model. And that's all I need to do. Well, anyway, so he ends the last bit, which is unfortunate. I should have played the next 10 seconds, because he says, the Feynman point still holds. I think, obviously, I've gotten rid of the Feynman point, okay? Until you can explain to me how a school of fish can come towards me without more fish in the school moving towards me, spending more time moving towards me. There has to be fish, more fish, in the school moving towards me than fish going sideways as a percentage of time. So explain to me how it's possible for the school of fish to move towards me if more fish aren't spending more time moving towards me. Then you can say Feynman's point holds. Till then, you're out of luck, because his point doesn't work. Anyway, alright, so the electron thing, again, these are things I will give you descriptions, but I mean, you can think of the electron as a rope, a string, that has movement. So, like a gyroscope or like something else, it's going to maintain a shape, you would assume, or something by, some sort of dynamic force. I would imagine even in space, once it has a shape, it'll keep its shape. What conforms it to a shape, that gets a little more complicated, right? Whether how the electron actually connects, whether it's rings caught on each other and they just pull on each other, caught inside each other, ring, ring, ring. Could be a lot of ways you can describe how they are connected and why they have some potential to move, but they have a limited potential to move, and that's what breaks them, is when they can't go where they want to go, so to speak, and they crash into each other and shit happens and they have to fly loose, and photons fly loose. But yeah, so I can give you a description. That's the essential quality of it. It's just a moving string, a rope, or whatever you want to call it. And I'm saying that basically the photons that make electrons, I believe, okay, I don't have anything. I just think this is the reason why the kinetics are the way they are. This is why they kinetically react the way they do. Is because they are locked into each other. The photons have no wavelength in the electron. The electron just collects photons. It doesn't collect their wavelength. It just collects the photons. So when energy goes into an electron, when it gets more energy, it collected a photon. It didn't collect a wavelength. So they're all smashed into each other. Smash, 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 smash. They're just photons. And they can be anything when they're released. They can be radiation, or they could be ultraviolet light, or they can be radio waves. They can be any kind of energy. It's because there's no energy now. in the sense that they're only photons. Their energy is a photon, not energy at a wavelength, which is an important distinction, I think, because now we're back to time again, and time, the relevance of time. But anyway, so I believe that's the configuration, and that's what creates the kinetic problem, where because they are tied to each other, now when something hits them, there's a problem. Houston, we have a problem in that the kinetic response is now disrupted because of the fact that they are tied to each other. And it's only the fact that if you hit one head-on still, you know, say if it is a rope and the two ends are open, or some other thing, it would still be very kinetic. But if you hit one in the side, you break it. You break the connections between the photons and probably create disruption in the pattern of the electron. That's what creates the angular problem that the electron collects. The electron collects a wobble because of the breaking of its chain and then re-knitting of it, so to speak. And the kinetic response, the angle of the kinetic response is going to be changed because of that breaking pressure, you could call it, or whatever you want to call it. But yeah, it won't be as clean as the purely kinetic response, one could argue. It's like breaking, it's like pool balls and they're connected by a little bit of glue, and a little bit of glue between them will screw up their trajectories, something like that. But again, I don't have to go into that detail to make this point about, number one, about gravity, about how relativity is wrong, how there's absolute velocity. These are the important subjects, but you know, I don't mind going into these kind of details, but these are details I don't have any obligation to go into a great deal of detail about these interior structures, just as nobody's doing that with the standard model. Nobody's giving you that kind of blueprint. So I don't think I have to go into that detail to explain that this is what the electrodynamics is. We already know some of that from quantum mechanics. We certainly know what happens. Photon goes in, certain thing happens, photon comes out. You know, sometimes it's 1 out of 16 times it does this, 1 out of 8 times it does this, 1 out of 4 times it does that. We know these probabilities, so I don't have to do anything but explain what we see as phenomenon. I don't have to go deeper than that. But I don't, like I said, I don't mind doing that, but I just don't want to be held to it like somebody's going to give me a gotcha thing because I said this and that doesn't happen. Because that's just speculation right now. It's not one of my bullet points yet. The gyroscope thing might be one soon, and frankly, this idea of the photons being stuck together, you know, no wavelength, you know, that's looking awful good to me. So anyway, I think I covered. So yeah, the electrons and their speed. Yeah, again, they have two things. They have the spin, okay, how fast they spin, how fast the electron spins, plus the speed of the orbit itself. But obviously the spin and how fast the electrons is moving are proportional, inversely proportional. The faster it spins, the slower it can move. The slower it spins, the faster it moves. But it can't do both. So the spin and the speed are related to each other. But more importantly is, once it's in an orientation that's directional, the bigger the electron gets, the more it will eat in that direction. So more energy means more velocity for an individual electron, let's say. That kind of thing. But yeah, I do believe that's another point to be made somewhere in here, is that the nature of electrons are that they can collect photons and release them. They're like little batteries in a sense, and that's sort of the nature of what's going on in the whole electrodynamic material sphere, is this idea of absorbing photons and then releasing them in bursts of flash and fireworks and whatnot. Anyway, I'll be back. Well, let's play a little bit. This is for
technical word. Fine. There was one other thing, wasn't there, that I dealt with that I felt you inadequately dealt with, but we'll move on.
Yeah, well, that's just kind of a bullshit move. So again, but whatever, you know, I'm going to say that your inane, simplistic, almost preposterously irrational qualification of my explanation as arbitrary and random is insipid. So yeah, you're going to have to do a lot better than that, jackass. Because the fact that schools of fish move, migrate, is a fact. And it has nothing to do with random or arbitrary. It has to do with what the fish are goddamn doing. Shit for brain. So again, if you're going to be insulting, I see. So you don't see how that's insulting. I don't think you adequately dealt with any of my points, and one of the ones I don't think you adequately dealt with, I can't remember at this point, but there was another one that you were full of shit on. And don't you see how that's exactly what you're saying? And that anybody with any kind of rational integrity, any sense of I'm entitled to a little bit of fucking respect, would say, hey, fuck you, cunt. Prove it, or fuck you. I spend my time proving it. That's what I did with the Feynman argument. I demonstrated how Feynman was wrong. I didn't just waste my time saying, no, Feynman was wrong. I proved he's arbitrary and random. No, I didn't do that. I proved he was wrong by giving examples of how light beams do not carry lateral momentum. I can move this around all the fuck I want, and the photons aren't going to be going like this in space. I mean, in the sense that the ones over here are going to go over there, the ones over there are going to go over there, and none of them are going to go, I'm going this way. Yeah, none of them are going to do that. Shit. Till next time. Alright, somewhere around 1650, so now he's talking about the relativistic nonsense elevators thingy bullshit, whatever. And, okay, you know, what we both should concede is the guy who made the video did it poorly, right? You know, look, velocity will create a straight line when you curve it, okay? And then acceleration obviously will create a curved line because acceleration necessitates the increase in velocity, which will create an arc, you know, on a graph. It'll go bendy. Okay, no doubt about that. I'm not even disagreeing about that. I don't even care. So let's just say that, okay, this is acceleration. All right, that the irony of the acceleration is it's faster than the speed of light. Okay, so you know, Hythloday is saying, well, he doesn't have to tell you what g is. G is any speed. Well, the any speed that this particular elevator is going is the speed of light. All right, this is, and that's quite obvious to see, right? If a photon can get from here to the bottom of the elevator, then obviously these two distances are proportional. So the speed of light, you know, it's like d1. This is d1. This is d2. The same amount of distance was covered from both positions. Okay, from the lateral and the you know, it's the hypotenuse, but it's the same triangle anyway. So d1 equals d2, and so dx equals c. So either one of these d's equals the speed of light. It has to be traveling the speed of light for it to end up in this corner. You know, if it ended up short of the corner, it would have been even faster than the speed of light. So you're making a thought experiment out of photons, and you have an elevator going faster than the photon, accelerating faster than the speed of light, essentially. To be able to do this experiment, it had to start off slower than start off somewhere slower than the speed of light, I would imagine, for you to have even a rational thought experiment, right? So it had to start off slower than the speed of light, and to catch up, to get up in this corner, it actually had to accelerate faster than the speed of light. So by the end of this thought experiment, this elevator is actually going faster than the speed of light. And you're going to tell me that I should learn something from this idiotic arrangement of nonsense. And you're going to tell me that this tells me something about reality. This says absolutely nothing about reality. Again, I can give you the school of fish example again, but if the fish can only go 30 miles an hour, and all the fish are going 30 miles an hour in a direction Well, they're not doing any school stuff anymore. They're not doing any figure eights anymore. They're not doing any loop-de-loos. They're not spelling Gary's name. They're not doing a goddamn thing except all going in one goddamn direction. So they're not going to be matter anymore. So if we call the school, if we define school as being something with patterns, and we call matter something with patterns, there's no patterns if you're moving the speed of light. It's all energy moving all one direction. So if you move matter the speed of light, there isn't any matter anymore. There's just a big blob of energy moving the speed of light. A big blob of fish. A big blob of photons. So anyway, the concession I would make is the guy's video was pretty poorly done, because he should have just made this, instead of making this dot so low, he should have made it even higher, so then he could have done the arc thing. And not look this stupid about trying to make a roundy out of a straighty. So that was his error. But the fact that the elevator's moving, you can deduce how fast the elevator's moving from the fact that the light traversed this distance and this distance down in the same period of time. So from that you can deduce they're both going the same speed, which is kind of a bogus experiment, right? Right. So let's play a little bit of this. But I mean, this is not worth arguing about. Obviously, the guy did the experiment poorly. I didn't have any confusion about it. I'm just saying that I don't care whether it's acceleration. I don't care whether it's velocity. All I'm saying is light doesn't have momentum going up and down. Duh. Again, I'll point out, if I shoot this thing as I'm moving, I blip it. Little blips of light coming out of it. Those little blips of light aren't going to keep going with the motion of my hand. No, ain't going to happen.
Exactly like, analogous to. And so it's not the case. It's still put forward that a photon leaves with the when you set up a light clock. See, this drawing I thought was insinuating, pointing towards the idea that the light clock, which is used to demonstrate.
Let's go through this again. The light clock is this other insipid example of nonsense, right? So you put a mirror here, you have a gun shooting photons, you have a sensor here detecting, okay? And so you shoot the photons up to the mirror, they bounce off the mirror, come back into the detector, right? This is your clock. So this will happen a certain time because it takes a photon a certain amount of time to do this, and blah blah blah. They call this a clock of some kind. It'd be a piece of shit, but anyway, their theory is you can move this clock at preposterously fast speeds. Go ahead, move as fast as the speed of light. We don't care. And that somehow the photon's going to hit the mirror, even though the mirror just went flying off at 186,000 miles a second. Okay, the mirror just took off that way. This photon is somehow going to figure out how to go that way and hit it. No, that's not going to happen. The photon's going to shoot right the fuck up that way, and it's not going to hit a motherfucking thing. Because this is all just fucking preposterous nonsense. I mean, this isn't a thought experiment. This isn't a clock. It's a piece of shit. It will not tell time. Trust me. Build one, and I'll show you. Okay, if we put it in an accelerator and I can start moving it with any kind of speed at all, I'll show you how it's going to fail.
Special relativity, that you see light bounce up and down in your lift at a constant velocity. I thought, well, if it's really trailing off, then you can't have such a light clock. Inmendham would be right, but as again, no, you do see the light clock bouncing straight backwards and forwards because it has the angular momentum also.
Yeah, well then again, when I look at the sky, if somebody point out where Venus is, I can say, when I see Venus, I'll say, that's where Venus is right exactly now. Right now, because the light kept up with it. As Venus moved, the light moved with it. It kept its momentum, so now it's at the proper position. So when I see the light from Venus, it's not 10-minute-old light. I mean, it's still 10-minute-old light, but it's in the actual position that Venus is in. So Venus is fooling me. It's giving me its old image, a 10-minute old image, but it's showing me the image in the right location. So let's redo Newton again, right? We had to fix Newton because he didn't realize there was a 10-minute delay. Well, now let's refix it again, right? Because somehow that's wrong, because that was the actual position of the planets. They weren't 10 minutes off. They weren't 15 minutes off. They weren't a half hour off. Light cannot have two momentums. It goes one way, very, very fast. It doesn't do anything else. It has a one fucking track mind. It doesn't give a fuck about how fast you were going when you launched it. It's gone. Okay? It's gone. Alright? It's gone. It's not doing any sideways lateral crap.
Slip of the mouth. That's your fault, Gary. The directional vector momentum of the spaceship, such that you see it travel straight, but an outside observer sees the photon move to the place where the mirror will be. Anyhow, but if it's accelerating, if the spaceship's accelerating, then you can't have a light mirror clock in the accelerated reference frame for the reasons that this video describes.
Yeah, well, again, it doesn't matter. Acceleration and velocity, it's the same game, okay? One of them is where you're acquiring velocity, so obviously acceleration is velocity in the sense that you're acquiring velocity as you're accelerating, but that's really the only distinction, technically. And quite obviously, any change in a system, the system is going to be disrupted because there's a change. If all the gyroscopes are now getting moved around inside your body, then obviously they're going to be a little bit, there's going to be some disruption. So you're going to notice the difference between acceleration and velocity. Okay, only because your system is going to habitize to the new condition. But the habitizing to a new condition doesn't mean the new condition doesn't exist. So the fact is, the acceleration is always, the consequence of acceleration is always there. The velocity exists. You don't lose your velocity merely because you flew somewhere into some warpy time bullshit. Yeah, I don't know what else to say to that.
I think the drawing may well be in slight error, but
in catastrophic error, actually, for the point he was making. He made a catastrophic mistake. So yeah, it's no big deal though. I mean, we detected it and we've said okay, so it's done. So yeah, I'll see if there's anything else in the end of the video, the last couple minutes. I'll be back. Oh fuck, only 50 seconds left. Well, so he was mocking me for using acceleration and whatever, making a mistake. And the guy just made a physics video on general relativity and made a pretty profound mistake in his video, right? And you're going to go mock him? Are you going to do that half of the day just for fun? Go mock that guy, okay? Because that's all you have, right? All you have is mockery and bullshit. You don't have a real argument to make, right? So, yeah, fuck you. You suck. You just keep playing your game, okay? Instead of pointing to the guy's video and saying he blew it, you sit there and blame it on me. He takes a straight line, turns into a crooked line, because he made a mistake, and you can't just say he made the mistake.